Okay, so I'm gonna share the screen. I made a piece of notes, and I will go over what is covered in the class. So basically, I think the most important topics are binomial distribution, hypergeometric distribution, um, and their interrelationship. So it's probably like a review session, but I provide more solid examples. So can you see my screen now?
Yeah.
Yeah.
Okay, sure. Great. Okay, so for binomial distribution, suppose like I have 5 coins, and those coins are not fair coins. So I mean the probability of getting a head is 70%, getting a tail is 30%. So what is the probability that I find the sequence of head, tail, head, head? The second one and the third one were tail, and I just black it. So to answer this question, you just need to multiply the probability of each observation. For the first one, getting a head, the probability was 70%. The second one, getting a tail, the probability is 30%, and so on and so on. You just multiply them together because those are independent events, right? The result of the first toes doesn't influence the result of the second toes. So just multiply them together. And what you get is zero point 0.7 to the power of 3 times zero point 0.3 to the power of 2. And in the class notes, if you remember, that is the first formula here. Um, but like professor doesn't give any concrete example, I guess. So can you see this p to the k times uh, times 1 minus p to m minus k. So basically this is the formula, how you find a specific sequence. And p is a probability of getting a head, and 1 minus p is a probability of getting a tails. So here in my example, I just use a very concrete example to show how to utilize this formula. And what you can see is my probability of finding another specific sequence, which is tail, head, 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 tail, or the third one, tail, tail, head, 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 right? The two tails uh, show up in different positions, but their probability is exactly the same, right? So you just multiply the different probability together. Um, so in first line, it's somewhat different because the zero point 0.3 and zero point 0.7 show up in different positions. But you see, in the second line, all of them can be written as 0.7 to the power of 3 and 0.3 to the power of 2. So this example gives you intuition like how to utilize this binomial formula. Okay, so but when things become a little bit difficult, what if my question isn't I write you a specific sequence and ask you what is the probability, but instead I will ask you how many sequences can we find with 3 heads and 2 tails? This is very important because in realities, many times we don't mind like which 2 positions you chose a tails, which 3 positions that you got a head. But instead, I just curious about the probability of what is the probability of finding 3 heads and two tails, right? I don't specify which positions I need to get heads and which positions I need to get tails, and it's very common in real life those kind of probability. So so the professor gives us this equation, the required probability. Um, why this is the case? Why this is the case? Yeah, I am recording this Zoom session. You see, this is a pretty long formula, and I don't anticipate like some of you can know this like without understanding, right? It's not something for you to remember, but for you to understand. For the last part, p to the k times 1 minus p to n minus k, this is just something we find in the previous page, and I think you understand what this means. But what about the first, this huge thing, the n factorial divided by n minus k factorial times k factorial? So to understand how to solve this problem, like the what is the probability of observing exactly k hats in n tosins? How to solve this problem? It's right. The description was pretty easy, but to solve it is not that easy. To understand this, what we're gonna find is we should first know about permutation and combination. These two concepts. So suppose I have five candidates here, and I will choose one president and one vice president from these five candidates. How many options do I have? So for president, I have five options. I can choose either one, two, three, four, or five. And then the president position is settled. I have four candidates left. So for vice president, I have four options. No matter like which one is the president, then I have four candidates left, and I can choose either one to be vice president. So so this is why how we call the five permutation two. Five permutation two means you choose two people from five people and you allocate them different roles. So it is 5 times 4. And many times, because it's not, it doesn't generate to like n, the n case, like n permutation k case, it's very difficult to write a formula like this. So mathematician just did something pretty weird, but it makes the formula seems a little bit more easy. So we just multiply 3 times 2 times 1 on the denominator and numerator. So to make that like 5 factorial divided by 3 factorial. So this is the maybe some mathematicians think this is better looking. So they use those kind of notations to form this formula. And in general case, what is n permutation k? You can see 5 permutation 2 is just 5 times 4. And you just like you just add all the factorial starting from 4. So you add 3 factorial, both in the denominator and in the numerator. So it's 5 factorial divided by 3 factorial. And for general cases, when n permutation k is just n factorial divided by n minus k factorial. You can do some simply mental experiment, and it's very easy to make sense. And like for 5 permutation 2, it's 5 permutation 5 factorial divided by 5 minus 2 factorial, which is 3 factorial. So so this is permutation, means I'm choose k from a sample of n, and they have their own role. And how many combination, how many options do I have? I will use permutation to calculate that, and this is the formula of the permutation. But now what we are what we're curious is not the permutation, because we simply want to solve the question how many sequences can we find with 3 heads and 2 tails. I just need to choose 2 from 5 instead of allocating them president and vice president. So these two are different questions, and you can guess, like if I just choose 2 from 5, my answer, my way of allocating the two is a little bit lower than permutation, because in permutation I have already choose 2 from 5, and then I still have 2 options. I can allocate the first one with president and the second one with vice president, or I can do the opposite way. I can allocate the first one with vice president and the second one with president. So permutation 5 permutation 2 is probably larger than 5 choose 2, because 5 choose 2 I don't need to allocate them rows, so I have lower options. But how to calculate that exactly? I will I will use a step-by-step method. So we're still thinking about permutation. This example, 5 candidates, I need to choose 2 candidates and to be president and vice president. But first, instead of using 5 times 4, first we choose 2 people among 5 candidates. And this is 5 choose 2. This is the problems that we want to solve. And second, we allocate president and vice president to 2 people. So after the first step, I only have 2 people. The last 3 candidates just go home. I only have 2 people now. And I allocate the president and vice president to 2 people. So another way to calculate 5 permutation 2 would be I first use 5 choose 2. This is the notation of 5 choose 2. And then I multiplied by 2 permutation 2. The 2 permutation 2 is simply how many ways we can allocate the president and vice president to 2 people. Like I only now have 2 candidates now, and I need to assign president and vice president. So my option is simply 2 times 1, because for president I have 2 options, and then I only have one person left, and that person is automatically allocated to be vice president. And so this is 2 times 1. It's pretty similar like here, 5 times 4. But to get more familiar with the notation, I just use 2 permutation 2. It's just I have 2 people and I have 2 rows. I want to allocate them. So it's 2 permutation 2. So from this one, we can see that okay, we find a way to calculate 5 choose 2, because 5 choose 2 is simply you make this to the other side of the equation. It's just simply 5 permutation 2 divided by 2 permutation 2. In general cases, um, it's you just mimic the first line, 5 permutation 2, right? In general cases, if that's n permutation k, it's just equal to n choose k times n permutation times k permutation k. And I can calculate n choose k. What is n choose k? Just it's just n permutation k divided by k permutation k. And if you employ the formula for the n permutation k here, you just plug in, you'll find this is the formula for general case. And by the way, the k minus k factorial, 0 factorial is equal to 1. That's the by regulation. So you get the general formula for what is n choose k. What is n choose k? This formula. So I guess somehow you understand this formula. I don't think the professor like walk you through how to get this formula in class, but that's something you can understand. By understand this, so our last step is to solve this problem. What is the probability of observing exactly k heads in n tosing? How they find this formula? It's pretty easy. Just like so first, if I have a specific sequence, the probability is this one. And then I have already calculated how many specific sequence I can find, right? So I just time them together. So for example, I ask you what is the probability of getting two tails and 3 heads. Like in old method, what I'm going to do is I just draw those kind of things. I just draw those kind of things. And every one, the probability is simply here. but I don't know how many times I need to draw. I draw another one, I draw third one, right? So and then I add them probability together, which is essentially this thing times 3, right? If I just draw 3 sequences, this probability times 3. But I don't know how many this kind of sequence can I draw. But here I just come up with an idea. I don't need to draw them anymore. I know like 5 choose 2 is what? I just plug in numbers in this formula and I know what is 5 choose 2. So I know how many sequences I can draw like this. And another way you may find out is 5 choose 2 is actually equals to 5 choose 3. And you could think about why that is the case. So first, if you plug those numbers into the formula, you will get the same number. But essentially, how you understand this is I choose 2 heads from five toesing, right? I get those sequences, and that is essentially equals to I choose 3 tails from the 5 toesings. I get exactly the same result. So what you'll find is if um, like k n choose k is essentially equals to n choose n minus k, and it's something make your calculation a little bit easier, maybe sometimes, because so for me, I usually want to calculate those downer number, those lower number to be a number which is like smaller. That's something I will do. So if you ask me to calculate 8 choose 6, I will just calculate 8 choose 2. And I think that's somehow a little bit easier if I plug a number to the calculator. That is a small trick. But anyhow, what I'm going to calculate the probability was just I used 5 choose 2. This is how many rows I'm going to choose from. I'm going to choose 2 from 5. Plugging the number to this formula is just 10. So the probability of observing 3 heads and 2 tails is simply 10 times one specific sequence. And I just calculate the probability of one specific sequence. And if you see the number here, 10, I don't think if that reminds you something, but 5 permutation 2 equals to 20, and 5 choose 2 equals to 10. There is a relationship actually, and it's easy to understand because when 5 permutation 2 is just simply I just choose 10 people, I just choose 2 people from 5. I have 10 methods, I have 10 options, and then I allocate them with president and vice president. So for every option here, for every 10 options here, I have 2 other options to allocate them with president and vice president. So that's why 5 permutation 2 is exactly 2 times as 5 choose 2. But that doesn't apply to other situation like it's 5 choose 3, so it's pretty different. If that's a 10 choose 6 is much more different and much more difficult. So just in this case, intuitively you can see it's just the 2 times relationship.
I have a quick question. Is
Sure.
n always the total number of
Yeah, that's
choosing?
true. That's true.
So n is always the largest number or the total.
Yes.
Wow. And then k is how many choices you have.
Yeah, a K is not how many choices you have, like your result is how many choices you have. K is how many times you want to observe a specific result. For example, here, my K is tails. My K is 2 tails. I want to get 2 tails. Or in other words, I want to get 3 heads. So here, K can be either 2 or 3, and the
Mhm.
results would be exactly the same. So
Okay, so that was your point of saying like 5/3 or 5/2 are exactly the same.
yes, that's true.
And then your other example, I forget, it was like 12 minus 8 or something over 8
Yeah,
or
yeah.
12/4 or something.
True,
Something like
true, true. 12 choose choose 8 is essentially equals to 12 choose 8. So as long as you make your like lower number, that the sum was exactly equals to the n, then they are essentially the same. Like n choose k. Oh shoot. So in general case, it's like n choose k equals to n choose n minus k. This is in general cases. So so um, so that gives you like a way to understand the formula that was discussed in the class. Um, and I guess like in your exam, it's open book, so it doesn't matter if you can remember or can't remember this formula. But the core thing is like you have to know how to apply this formula. Like if I give you a question, I give you a problem, how to actually we have a problem in this home assignment. If I give you that problem, how you can calculate the probability. So after this, I'm gonna talk about the hypergeometric um, distribution, and after the discussion of the binomial, I think it's much easier. So for example, I have 3 reds and 2 blacks.
Sorry, I have another
Sure,
question.
sure, go ahead.
Um, do you think if there's a one of the homework questions that the binomial would apply to, can we do that one just to see it in like as an example?
Okay.
Thank you.
But first, can you see the home assignment here on the screen? Okay, sure. Great.
Yeah.
So for the first question, a gambler offers you to pay even odds if you get 9, 10, or 11 heads in 20 tosses. Should you take the bet? In other words, should you take the bet means the probability is over 50% or lower than 50%. So here, what you're gonna do is you just want to calculate what is the probability of I getting 9, 10, or 11 heads out of 20 tosses. And here we can split this question into 3 parts. What is the probability of I getting 9 heads out of 20 tosses plus the probability of getting 10 heads out of 20 tosses plus the probability of getting 11 heads out of 20 tosses. That is the probability as a whole. So like I try to solve the first one. What is the probability of getting 9 heads out of 20 tosses? Actually, we have already solved that. You see, here this formula is for what? Is for what is the probability of observing exactly k heads in n tosings? And now my question is, what is the probability of observing 9 heads in 20 tosings? You just apply this formula. And then the second question is, what is the probability of observing 10 heads in 20 tosings? And then you calculate what is the probability of observing 11 heads in 20 tosings, and you just sum up your answer and compare that final answer to 50%. If that's higher than 50%, you will agree to gamble. If it's lower than 50%, you will not agree to gamble. So pretty much that's how to solve this problem.
So if I wanted to write it out, it would be n over 20 times n over, I mean, sorry, 9 over 20. Like using the n over k formula, you would put n over 9 over 20 is equal to 9 over 9 minus 20. Is that how you plug it into the formula?
You will use wait a second. So you want to have 20. So how many sequence? You want to know how many sequence? So this is how many sequence I can find, right?
Mm-hmm.
This is how many sequence I can find. Um, for example, it's 9 heads followed by 11 tails. This is one sequence, right? Maybe I find another sequence. It's 8 heads followed by one tails, followed by another head, and then the rest was tails. That is another sequence. So, so first I need to calculate the probability of a specific sequence. Remember that? My probability of a specific sequence is here on the previous page. We will utilize this formula. In this case, P and 1 minus P was both 50% because I'm tossing a fair coin. And K equals 9 because in this sequence I have nine heads, I believe 9 heads and 11 tails. So for a specific sequence, my probability is just 50% to the power of 9 times 50% to the power of 11. And I highly recommend you to use calculator, or if you don't have an advanced calculator, maybe you can just Google like statistical calculator and you find something. So it's impossible to do it by hand. So this is one specific sequence. And now what we're gonna do is I want to find how many sequences in total. Here is my way to find how many sequences in total. And if you just want to plug in the number, so my hint was that is 20 factorial divided by 11 factorial. 11 is just 20 minus 9. 11 factorial times 9 factorial. And still, you need to utilize a computer to calculate this. And you just use those many options to find a specific sequence times the probability of one specific sequence, and you get what is the probability of getting exactly 9 heads out of 20 toes. And again, this whole stuff needs a calculator. It's impossible to do it by hand, and I guess probably an advanced calculator is preferred. I mean, on iPhone, I don't think like the calculator on iPhone could calculate those stuff. I'm not sure, but maybe you can try that.
Wait, really quick. Is it Why is it 20 factorial over 11 factorial times 9 factorial? I thought it was just 20 factorial over 20 minus 9, which would just be 11 factorial.
Okay, because we have come up with this formula, right?
Oh,
This one,
okay.
and
Gotcha.
if you divide, yeah, if you divide here by here, you'll find the denominator was like 2 factorial, and times them. This
Using
is
the
how we
combination.
come up with this formula. And if you don't remember this formula, it's totally fine because it's like your exam is open book. You can utilize any notes and any public resources to finish your homework. So you can always find your notes here. Professor gives you this formula, like what is n choose k and what is the probability of observing um, K heads in untosing. Those are the formulas here.
Gotcha.
But
Okay, thank
again here, this is just 9, 20 choose 9. You need to use this and multiply it by the probability of finding a specific sequence. So that is my, uh, this is ugly handwriting. I don't have a tablet. It's like 1/3 to the power of 9 times 1/3. 1/3 is simply the first 1/3 is the probability of getting a head, and here the second 1/3 is the probability of getting a tail, and to the power of 11 because I need nine heads and 11 tails. This is essentially what I talk about here. So if you didn't catch it, you can watch the recordings and see how I come up with this formula. Because every specific sequence, the formula is the same, as long as I have two tails and three heads. And here in this example, as long as I find 9 heads and 11 tails, the probability of a specific sequence is simply here. So I use those two and I multiply together, which is the probability of getting 9 heads out of 20 toesing in professor's notes. Um, the whole formula I'm writing here, the whole thing is this, and you can review the formula, and you can read this page, these slides after the review session. You maybe find it's okay. I understand all of them. But notice that this is only the probability of getting 9 heads out of 20 toes. You still need to calculate yourself what is the probability of getting 10 heads, what is the probability of getting 11 heads, and you sum them up to compare them with 50%. So 9 heads, I'm just calculating the probability of getting 9 heads out of 20 toes. This result was absolutely lower than 50%. So you need to add those three together and compare if that's greater or smaller than 50% and make your decision. Basically, this is the first problem, and it's a very standard and a very important binomial probability distribution. Okay, so if there's no more question, I'm gonna continue talking about hypergeometric distribution. I think it would be much easier after our discussion before. So if I have a box, and inside the box I have 3 red balls and 2 black balls, what is the probability of I observing two balls and they are both red? Like I just draw 2 balls randomly, and all of them are red. The probability is simply 3 over 5 times 2 over 4, because the first drawing, I need it to be red. What is the probability? I have 5 in total, 3 reds. My probability was just 3 over 5. And then, because I'm not putting my ball back into my box, so now my box only have 4 balls in total, and among which 2 balls are red because I have already draw one red ball out of the box. So here, after the first drawing, I have 2 reds and 2 blacks. So what is the probability of drawing another red in the second drawing? It's just 2 over 4. So here is my probability. So here is my probability of first 2 being red. Another way to think about it is using the combination, right? The probability of drawing 3 balls, obtaining 2 reds, is here 5 choose 3 is the total options I have, because I'm drawing 3 balls out of 5 balls. How many different options I have? 5 choose 3. But how many 2 reds options I have? So this is all the options. Maybe the 3 balls are reds. Maybe it's 1 blacks, 2 reds. Maybe it's 2 blacks and 1 reds. But I need to find out how many options do I have to draw 2 reds. So it's also intuitively easy to understand. I just need to draw 2 balls out of 3 red balls. And then I need to draw 1 black balls out of 2 black balls. And I multiply them together. So it's 3 choose 2 times 2 choose 1 divided by 5 choose 3. So how to solve this? So using the combination, if I want to solve first 2 being red, how to set up my formula? In the denominator, it's 5 choose 2 because I'm choosing 2 balls out of 5 balls in total. In numerator, I need to find out how many ways I have um, to choose 2 reds out of 2 toasing. So first I have to choose 2 reds out of 3 red balls. And I have to choose 0 blacks out of 2 black balls. This thing is just simply 1. So for this thing, so as long as it's something choose 0, you don't choose anything. You only have one option. So if you plug in those numbers to the formula, it's just essentially to what I write here, 3 over 5 times 2 over 4. I think it's 3 over 10. This is so actually I have two approach to answer this question, and I also the formula is given in the slide, I guess. The probability of first leg to be read, like because those are just all abstract letters, so so you may again look at those formula and some examples here, and you may find it easier to understand. But again, I want to particularly talk about what is the interrelationship between binomial distribution and hypergeometric distribution. So instead of 3 reds and 2 blacks, what if I have 30,000 reds and 20,000 blacks? For the same token, I want to choose 2 balls. What is the probability that I obtain two red balls out of the 2 joins? Again, it's like here, pretty much similar. Pretty much similar. I just the number is larger. The number is larger. I use 30,000 divided by 50,000 times then after the first join, I only have 49,999 balls in total, and among them only 29,999 balls being red. So for the second toasting, the probability of getting a red ball is simply here. This is comparable to the 2 over 4. Those two are comparable, and these two are comparable. But what you find here is this number, since my number is too large, and you just divide it by 1 from both denominator and numerator. This is essentially pretty close to 3 over 5. To 3 over 5. So when your number is large, you can use binomial distribution to estimate the hypergeometric distribution. So here I say it's very close to 3 over 5 to the power of 2, 3 over 5 squared. But here you cannot use this. If I only have 3 reds and 2 blacks, it's not appropriate to use 3 over 5 squared because when you draw the second balls, the result is influenced is somehow largely influenced by the result of the first ball. Because I have drawn the first ball out, I only have 4 balls left and 2 red balls left. So I use 2 over 4. But here, I think it doesn't matter. I just think this is 3 over 5. So that is something Professor Bartman mentioned in this slides, that that when the number is very, very large, we can use hypergeometric models to estimate the binomial distribution. And by the way, in the homework 2, this problem is a hypergeometric model. And here, for the sake of accuracy, and also it's the number is not large enough. So for this problem, you should use hypergeometric model instead of using binomial model to estimate it. So I need a very accurate number in this particular problem. Yeah, and I guess that's everything I want to talk about today. For the Poisson distribution and for exponential distribution, um, the formula was was easier, and I guess you're least likely to meet those kind of problems in your real life. So um, so yeah, I just want to talk about binomial and hypergeometric and their relationships. Um, and then like feel free to ask any questions, maybe related to the school course material.
Hey, Victor,
Yep,
how are you today?
that's pretty great. How about
All right.
you?
Here, I'm doing all right, man. Can't complain.
Sure, sure.
I just wanted to clarify what you meant here for number one. So you're saying to answer this, we would do 0.5 20 given 9 plus 0.5 20 given 10 plus 0.5 20 given 11, and that would give us a probability.
Hmm, not necessarily. It's not 0.5 times that. It's a probability of observing a specific sequence times 20 choose 9. And the probability of observing a specific question is actually 0.5 to the power of 9 times 0.5 to the power of 11. Because,
Okay.
yeah, because if I want to, for example, I have a very simple sequence here. What is the probability of I getting exactly 9 heads and followed by 11 tails? How will you calculate that sequence? Because the first 9 was heads, right? So you will use 0.5 for the first one, 0.5 for the second one, all the way 0.5 to the ninth one. So that is 1/3, one half to the power of 9. And then followed by 11 tails. So it's one half to the power of 11. So basically, you're going to use 0.5 to the power of 20 in total, because this is a fair coin, and no matter a heads or tail, the probability was just 0.5. So use this stuff. This is the probability of finding particular or a specific sequence, and you use this times 20 choose 9. This is the probability of finding nine heads out of 20 toasting. But then you still need to calculate what is the probability of finding 10 heads out of 20 toasting, 11 heads out of 20 toasting, and you sum them up.
Got it.
Here this question looks simple, but it's essentially here. Those big stuff, they're actually the same. If you understand this formula and you plug in the number, you will get the same number. These two are essentially the same, but
1 and 2, you mean?
here,
Okay.
this one and this one, they're actually exactly the same. This p to the k, in the home assignment, P is 50%. P is 0.5, and here K is 9. N minus K is 11, because remember we need to find 9 heads and 11 tails. And 1 minus P was actually 0.5 as well, because P is 0.5. So this is 0.5 to the power of 20. And the first stuff is how I calculate 20 choose 9. You just find it's exactly the same as here, and choose K. I just plug in 20 choose 9 to this formula, and I find the probability of finding 9 heads out of 20 toes.
Okay.
And then I still need to calculate what is the probability of 10 heads out of 20 toes, 11 heads out of 20 toes, and I sum them up compared with 50%. Sure.
Okay.
Sure.
Thank you.
Any other questions?
No, I don't have any other questions. Bye-bye.
Okay, sure. So I'm gonna stop recording and